This is lesson 4.5, volume of a cylinder. Before watching the recording, please make sure that you have a graph sheet of paper in front of you, a pencil, maybe different colored pens or highlighters, whatever you need. So if you need to pause the recording, go ahead and get those items now. Once you're ready, set up your page, write down today's date, and then lesson number is 4.5. So let's just connect the concept of volume to our previous knowledge, right? So volume, if you remember, is the amount of space. We'll start off with the definition. The amount of space a 3D object or three-dimensional object can hold. Amount of space a 3D object can hold. I should say actually measures the amount of space, right? So again, the definition of volume is that it measures the amount of space a 3D object can hold. Now, in Math 6, you would have looked at the volume of a rectangular prism. Now, if you have a straight edge, it's helpful to sketch this out as a visual. Okay, so I'm just going to draw so you remember what a rectangular prism looks like in terms of the layout here. And again, it's helpful if you do have a straight edge. Okay, so we've got our prism there. So remember, when you set up the formula, you would always take the length, the width, and the height as part of the calculations, right? So really, when you look at the formula for the volume of a rectangular prism, the volume formula of a rectangular prism involved L times W times H, right? That was the formula. Now, if you look at this even more carefully, really what you're doing, and I'll highlight it here, is you're taking the base, which is the length and the width, times the height. And actually what I should have done here, so that you can see it clearly in a three-dimensional capacity, is do this. Again, so you can see it, right? So here, you've got the length and the width, which makes up the base times the height. That essentially gives you the volume. So let's just do that here. It's really the base times the height. Okay, so I'm just going to box this out as a reference point, because when we move on to, we're going to move on to volume of a cylinder now. And what I want you to see is the connection, again, between the formulas. Because what we're doing, all you're doing with, when you're dealing with volume, is you're adding in that third dimension. You are multiplying 3 dimensions. Just remember that in both cases, okay? And remember the units of measurement, because it's 3 dimensions, you can have cubic centimeters or centimeters cubed, you could have millimeters cubed, or you could have meters cubed. Those are the most common units, okay? Now, let's move on to the volume of a cylinder. Okay, so we've got volume of a cylinder now. I'm just noticing this doesn't look, just gonna erase this part here. Oops. Sorry, excuse me. The rectangular prism wasn't looking right there. Okay, so now you got volume of a cylinder. Now, let's sketch out a cylinder here. So we've got two circles. You do whatever works for your sketch. You'll probably do better than me. Make it 3D a little bit. And there, that's the bottom, okay? So you know that a cylinder is made up of two circular bases, right? Okay. Now, what it is it is related to the volume of a rectangular prism. Even though it's a cylinder, it's the same principle for the formula. So what you're doing is you're taking, I'll do this in purple. Excuse me. You're taking the base area, okay, and you're multiplying the height. Okay, so again, you're taking the base area and you're multiplying the height. We know from previous lessons in dealing with a circle that the base area is pi r squared. Because remember, the area of a circle formula is pi r squared. We know the height in this case, well, we gave h as the height and the volume of a rectangular prism formula, so we're going to give h as the height here. So all we're doing, again, same thing, right, is the volume of a cylinder. How we calculate it is we're going to take the base area times the height. We know our base area is pi r squared, so I'm going to write that underneath, pi r squared, and we know our height is going to be h. So when we put it together in the formula, you end up with the volume of a cylinder is pi r squared h. So really the only difference between this and the area of a circle formula is you are multiplying that third dimension of height. Okay? So a lot of these features are similar, right? You're still multiplying 3 dimensions. And your units are going to be cubic centimeters, cubic millimeters, or cubic meters. So it's the same principle. Okay. Let's do one sample question because I really want you to understand that you have to show all of the steps carefully when you're applying a formula. So that includes substitution, that includes substituting the units of measurement and following PEMDAS. Okay, so here's one sample question. So what you're going to do is you're going to find the volume of a cylinder. I don't like that. Of a cylinder where the radius is 3.2 centimeters. And I also have to give you the height too. And the height, so make sure that you're given these dimensions. You could be given the diameter instead of the radius. That's okay, you can work out the radius. If you're asked to find the volume of a cylinder, the height has to be given either like this or in a diagram. And the height is 5 centimeters. Round your final answer to the nearest hundredth. Okay, so that's your question. What is the first thing you're going to write down all the time is you are going to write down the volume of a cylinder formula, which is V equals pi r squared h. That's the first thing you're going to write down. Now, I want you to pause it and think to yourself, what is the next step? What are you going to write down next? The next step has to be the substitution. okay? You have to substitute 3.2 and you have to substitute 5 centimeters in the next line. And you can do it all in one line, but it has to be the next line. Also, do not change the order in which the formula is written. Keep it the same. If it's pi r squared h, notice on the next line I'm recopying pi. Notice that I'm opening the bracket and I'm writing 3.2 centimeters. I'm substituting the number and the unit of measurement. I'm going to close the bracket because that is the radius. It has to be squared, okay? And the squared or the 2 is outside the brackets because you have not applied the exponent yet. You're going to open bracket because you have to substitute for the height. The height is 5 centimeters. Notice again, I'm substituting the number as well as the unit of measurement. Now this next step is key too. I need to see this next step in your work. Okay, now I'm going to write off to the side here as a reminder, especially in this case, you have to follow BEDMAS or BEMDAS or PEMDAS because that E, that exponent, has to be applied next because you have an exponent. You're going to recopy pi. Again, do not change the order of the formula. You're going to take the 3.2 centimeters and you're going to raise it to the power of 2 or square it. So 3.2 centimeters, I'll just write down a reminder here. So really remember it's 3.2 centimeters times 3.2 centimeters. Notice you're multiplying 3.2 times 3.2, but you're also multiplying centimeters times centimeters. So at this step, you're going to take it out of the brackets. 3.2 centimeters times 3.2 centimeters, if you're using your calculator, gives you 10.24. Now, because you're multiplying out the centimeters times centimeters, it has to be 10.24 centimeters squared at this point. Okay, because you are multiplying out the units of measurement too, right? Now, the next one is you have not dealt with the 5 centimeters yet, so keep the 5 centimeters in brackets and recopy it. So the volume of a cylinder formula requires this extra step, okay? So there is no, you haven't dealt with the 5 centimeters yet, but you've taken the 3.2 centimeters, you've multiplied it by itself to get 10.24 centimeters squared. It is really important you get this unit of measurement here correct, that it is squared, okay? That's what we'll be looking for. Now, you aren't done yet. So what you're going to do is you are going to, again, keep going. I'm going to recopy pi here, okay? Now, I'm going to recopy pi, and then the next or the final piece is multiplying 10.42 centimeters squared times 5 centimeters. So I'm going to do 10.24 centimeters squared times 5 centimeters. Okay, so now I have, I'm just going to keep this 51 and 2/10 centimeters. Now here's where it gets interesting too. You have centimeters squared times centimeters. At this stage, you have introduced and multiplied out that third unit of measurement, which is, or sorry, the third dimension, which is the height. So at this stage, it has to be 51.2 centimeters cubed because you're multiplying centimeters squared times centimeters. Now, if you left your answer as pi 51.2 centimeters cubed, just as a reminder, that is the exact value. Your work has to show all of these steps, even though I did ask you round your final answer to the nearest hundredth. So when you do that, and it becomes, I believe, 160 and 85 hundredths of a centimeter cubed, okay? So that is your final answer. So again, to reiterate, the volume of a cylinder formula does require more steps, but it's really important you understand that at this step, after you take out your squared measurement out of the brackets, you have to have the square here, centimeters squared there, okay? You have to make sure that you apply the exponent first. And then in the exact value step, it is already centimeters cubed, okay? So again, we have just connected all of our previous knowledge from Grade 6, when we dealt with volume, we defined volume. We looked at the volume of a rectangular prism formula again, the fact that it's 3 dimensions and the units, and then we connected that to the volume of a cylinder formula. But again, because we know the base area, which is pi r squared, you're just multiplying in and multiplying by the 3rd dimension of height, okay?